In this video, we will be dealing with lines in a plane and lines in space, and how those two things differ. First, in a plane, how many lines can be drawn perpendicular to a single line at a specific point? So first thing, because this is all being done by hand, we're not going to put arrows on the ends of the lines. You can think of them as line segments or lines, whichever is easiest. So let's say we have a line in this plane, and now I have a specific point on that line. I can draw one and only one line that is perpendicular to the original line at a specific point. In algebra, you learned that a point and a slope determine a line. So if this original line has a slope and this new line is perpendicular to the original, it has a specific slope, and we have a point right there. Next, in space, how many lines can be drawn perpendicular to a single line at a specific point? So here we have 3D axes, X, Y, and Z. To make this easiest to see, we're going to draw a line on this axis right here and think about the XY plane that it's passing through. So if I draw a line here, that's perpendicular to this red line. If we draw a line here, that's perpendicular to the line. Another line there, another line there. Remember, these green lines are all in the XY plane. This red line is perpendicular to the XY plane. All of these green lines are perpendicular to the red line. So then in space, an infinite number of lines can be drawn perpendicular to a specific line at a specific point. Next, in space, how many lines can be drawn perpendicular to a specific point on a plane? So let's say we have this plane here, and I have that point right there. We can draw one and only one line that is perpendicular to that plane. Again, you can think of it as if this plane has a particular pitch to it or a slope in space. If this line is perpendicular to it, that gives us a specific slope again, and we have a specific point, and a point and a slope determine a line. Next, if a line is drawn perpendicular to a plane, how many lines can be drawn in the plane perpendicular to that line, and what are the stipulations? So again, we draw a line that is perpendicular to the plane right here. Then any line that is in the plane that goes through the foot of this original red line is perpendicular to the red line. That is the line plane foot theorem. If we have a line in red here, perpendicular to a plane M here, then that line is perpendicular to any line in the plane, all of these in green, that pass through its foot. So again, it is an infinite number of lines. You can think of taking any of these green lines and rotating them around the foot of the red line to the plane. And that is where the line plane foot theorem comes from. 3D can be very hard to visualize, but if you go through this problem 2 or 3 times, it should become a lot easier.